Good evening. I am Professor Shalini Sahay from EC Department, Sirt Bhopal. Today I am going to upload my video on properties of discrete signals. As all we know that signal is something which conveys information, which is a mathematical function of one or more independent variables. Signals are divided into two types, that is continuous type, which are known as the analog signals, and second is discrete time signals and digital signals. Signal processing systems are classified along the same lines as signals: continuous time, discrete time, and digital systems. Discrete time signals are the signals uh, which are sampled at regular interval of time. So we will sample a continuous time signal at a regular interval of time, and we get the discrete time signals. These are the now, as all we know that these are the signals which are sampled at regular interval of time. Now the discrete time signals are represented in the form of the sequences, where x is equals to summation, it is represented by xn, and n is the integer which tends from minus infinity to plus infinity. And in sampling, it is denoted as XAMT, where t represents the sampling period, and 1 upon t, that is the reciprocal of time, it is known as the sampling frequency. This is the graphical representation of a discrete time signal, where on x-axis we have taken the n, small n, which is the integer value, and on the y-axis we take the amplitude of the signals. In the discrete time signals, here the time is discontinuous, but the amplitude remains the continuous. Now this is the sampling the analog waveform. We have considered one arbitrary analog continuous signal, and we have sampled this analog continuous signals into different samples. We have taken 256 samples of these continuous signals. Now the basic sequence operation which can be performed on the discrete time signals, like we can sum the two sequences. If we take one sequence which is represented by xn and the other sequence which is represented by yn, now it will sum the two sequences. Another operation is product of the two sequences. This is the multiplication of a sequence by a number. If we want to multiply a sequence by a simple arbitrary any number, then we can take as alpha dot xn. Delay or shift of a sequence, if we want to shift the sequence, we can perform this operation on the sequence. Now the basic sequence we can consider like unit sample sequence. So as we know that unit sample sequence whose amplitude is 1. Now the discrete time impulse. Now we have considered that the sample sequence is an impulse and whose location is at 0. So we get the impulse at 0 and amplitude is 1 and it is 0 elsewhere. So we have represented impulse and square bracket and represent that it is a discrete time signal and whose value is 0 for n is not equals to 0 and its value is 1 for n is equals to 0. Now this is the sum of scale delayed impulses. Now we can delay the impulses at the regular delay points. We have performed it like that. We have shifted the impulse on the left hand side as well as on the right hand side, and we have provided n naught is the delay, or in advance its value will be an integer. So we can write that xn is equals to is summation of k. We have taken an arbitrary integer value k, which tends from minus infinity to plus infinity, xk, and del n minus k. This is also known as the convolution of the input with impulse. Now, the unit step sequence. We know that unit step means its value is 1 for n is greater than or equals to 0, or it is 0 for n less than 0. So we have plotted the unit step sequence, and which whose exist for n or greater than or equals to 0. Now we can also perform the function as the unit step can be represented as the summation of the impulses shifted. So we know that impulse is located at 0. So this is del n. Now if we shift the impulse at 1, now the impulse is shifted at 1. We can perform this operation, and we can when we will sum all the these shifted impulse, we'll get a unit step function. Now the other basic sequences like this exponential sequence, it is xn is equals to a amplitude of the sequence alpha to the power of n, where a and a are the real numbers, a is positive and whose value lies between 0 and 1, xn is positive and decrease with increasing n. And for -1 less than a of its, if a lies between -1 and 0, then the xn alternate in sign but decreases in magnitude with increasing n. And if it's the magnitude of the alpha is greater than 1, then xn grows in magnitude as n increases. Now if we want to want an exponential sequence that start from 0 for n less than 0, then we will write in terms of xn is equals to a alpha to the power of n for n greater than or equals to 0. Otherwise, its value is 0 for n less than 0. And we can also write in simpler way that we want this exponential pulse only on the right hand side. So we can multiply with the unit step function. So the function will be simply written like this. Now the sinusoidal sequence, as we know that xn is equals to a cos omega naught n plus phi. Phi is the delay. So with the putting the different values of the n, we can find out the value for the xn. And if we connect all these points, we find that it represents a sinusoidal sequence. Now exponential sequence like sinusoidal sequence, we can also represent the exponential sequence. Frequency difference between continuous time and discrete time complex exponential or sinusoids. So here we can represent the sinusoid function in the term of the in terms of exponential sequence, and we know that e to the power of j omega naught plus 2 pi n. Here we have split into two parts, and we can consider exponential sequence in terms of the cos or sinusoidal waves. Now we can consider the periodic sequences, a periodic sequence with integer period n, and here also we can represent the periodic signals sequence. Periodic means which will repeat its sequence after a regular interval. For example, this is the periodic sequence. Here x1n is equals to cos pi n pi by 4, and we can say that the sequence will repeat, and to find whether the sequence is periodic and non-periodic, we'll put and find out the value of n, which is 2 pi k upon pi upon 4, and it is coming to 8k, and the k represents the smallest value of integer for which n will become the integer. So for the smallest value of k, we'll put k is equals to 1. Then n will become the sequence which will repeat after 8 number of samples. These are the other examples we can find out whether the sequence is periodic or non-periodic. And if we consider like this, x2n is equals to cos n, so it represents that it is not a multiple of 2 pi, and we can say that for any k integer, there is no integer. For any value of k, we are not finding the value of n as an integer, so we will say that this sequence will be non-periodic. High and low frequency in discrete time signals, we can vary the value of omega naught, and we can change the frequency of the sequence. So this is the discrete time system. Here we'll take the system. It is the connection between input and output, and where we are giving the discrete time signal as an input, and we are getting the output in the form of discrete. So it is all about fundamental of the discrete time system. Thank you.